Justin James to give us a talk about Angular unit testing in the trenches.
So Angular unit testing. How many of you have done any unit testing with Angular, 1 or 2? How many have just done the 2? I know you have. It's come a long way. I remember trying to do it in Angular 1. Didn't go very far. It was difficult. Angular 2 bakes it in right from the get-go. So we're going to look at a whole bunch of how to do unit testing, what unit testing even is, why you should do it. And we'll cover tons and tons of code examples. First and foremost, unit testing, nothing more than proof that your code does what you think it does. That's the whole purpose. We want it to confirm functionality, check regressions. Hopefully it pinpoints bugs. I'm amazed how many times we think our system's working and we start unit testing something in there, and we find all kinds of random things that we never knew were there. It also documents functionality. It's way easier to look at working unit test than it is to hope that the documentation that someone may have written is actually up to date. Qualities of unit test. Talked about should be automated, should look at a single unit of work, and should check a single assumption. Big disclaimer, you only get the advantages of unit testing when you're comfortable writing good test. So what are good tests? 3 things: maintainable, dependable, and runnable. We'll dig into each of those 3. So maintainability, they're not tricky. You shouldn't have a whole ton of tricks in your unit test and a bunch of code just to attempt to make your unit test pass. You should be able to read them. Just like you don't have a ton of comments in your code because it should be readable, your unit test should be just as readable. We want them to be easy to write. We definitely want them to be well named. You should be able to look at your unit test names and know immediately what the heck you're testing with that specific test without even looking at the code. The dependable side, you should always get consistent results. They should be isolated, so my components shouldn't be testing the services. My services shouldn't be making calls to my database. They should all have mocks in there, all just testing the single unit of work. They should continue to be relevant. If you refactor parts of your code out, take the test out. Even if the test still passes, just take out the test for that. And then test the right things. I see so many times people go, I want 100% code coverage. Chances are you're probably not testing the right things if you make 100%. You're testing every little thing that doesn't matter. So test the things that users care about. Test the things that are fragile. Make sure it's all the right stuff. On the runnable side, we want them to be fast, extremely fast. The faster they are, the more chances you're going to run them. If I give you a suite of unit tests and it takes you 10 minutes to run them, how often are you actually going to run those test cases? Not very often, and you might not even run them before you do code check-ins. You should be able to easily run them with a single click, or a single command. You should be able to repeat them over and over. If I run them 10 times in a row, they should give me all the consistent results. They should run fast. They should have everything working every time. And when you do have failures, it should pinpoint you right to the problem. You shouldn't just have a test that fails and you go, oh, now I got to rerun it and hook up the debugger. That's a bad test. Your error should say, oh, I expected to get this, and I didn't get it. And you can immediately start going and looking at what failed and where it's at. Huge caveat here, if you have bad coding practices, unit testing will not fix your bad development practices, no matter how hard you try. And I love this quote by Martin Fowler. Don't let the fear that testing can't catch all bugs stop you from writing the test that will catch most bugs. That goes back to the code coverage. If you can hit 50% code coverage and that's going to catch most of your bugs, go with that. If it's 80%, go with that. Don't strive to catch them all because you probably won't. We're humans writing code. We're going to put bugs in the code, and you just hope that your unit test will catch them. So that was a quick overview of just unit testing practices. In order to do Angular unit testing, you really do need a strong grasp of some basic Angular practices. You need to know the 4 blocks: modules, components, routes, and services. Those are the main things that we're going to look at doing testing for. We're going to use the Angular CLI for all of our testing. When you generate a project and everything, testing comes with it. 2 things you need for the Angular CLI: Node 6.9 or greater. And then you need to npm install globally the @angular/CLI project. Once you have that, I like to use Sass for my styling, and I like to have it include a routing module already. So I run ng-new, give it an app name, pass in the --style SCSS and --routing. It will generate you a full project with unit testing. As you use their generator, so I can generate classes, pipes, services, components, modules, they include spec files with them for you, already wired up with the most basic test that you can do, which says the component starts and it's true. To run the app, you run npm start, which behind the scenes will run ng-serve. Then to run unit test, it's npm test, which starts ng-test. So there's a little bit of tools to get this working. So already included with the project that Angular CLI creates is Karma configured, which is our test runner. Jasmine is our testing framework. That's the one that's actually going to do all of the testing for us. Then they include a whole slew of testing utilities within Angular. Stuff to make it easy to start modules, mock out HTTP traffic, mock out router traffic, get rid of some of the heavy Angular dependencies that we're not trying to test. Like you'll see when we start testing the router, we're not testing the router functionality, we're testing does our code route to the right spot. So they give you testing utilities already baked in so that you don't have to figure out how to make that work. And we'll see a bunch of those. When you start up npm test, you get a screen that looks similar to this. It'll compile your Angular project. It'll start up a Chrome browser for you that's brand new Chrome browser just for Karma. I will warn you, if you see it pop up and then you start opening tabs in it, the minute you stop your test running, it kills that browser window, including all of your tabs that you were using for other stuff. So don't use the Karma browser for other stuff. And then it runs through all of the tests. In this example, very bottom line, it executed 46 tests in 5.5 seconds. If any of them fail, it'll spit the output into the console here. Or this is what the browser window actually looks like. It'll spit the errors for any of the tests out, or it'll tell you all the specs that passed. It'll give you a nice view of each one of the specs, all of the functions that it's testing within it. And it'll have much more. Obviously, if I put all 46 on the screen, you wouldn't be able to read it. It also gives you the debug button in the upper right. When you click that, it opens an additional Chrome window that wires up all the debugging so you can hook up the Chrome developer tools. A lot of times, I will use console.log to observe data and events. If I'm trying to troubleshoot a test that's failing, and I'm wondering what data is coming out of it, sometimes the breakpoints are useful. Other times, it's just easier to use console log, and it'll all show up in the console for you like normal. So first test. So in order to have our bucket of test, we use the describe. So describe is just that bucket. I can have as many tests under it, which is what this it does. It is an individual unit test. In this case, it's called should pass. And they have all kinds of expects in here. So in this case, I expect true to be truthy. So there's other expects like to be null, to be undefined, to be defined, all kinds of different expects there. And thankfully, all the IDEs will pop up for the most part in a little IntelliSense and show you all of those options. And then here's one that would fail. I expect false to be truthy. And this should show a nice console error that says, hey, this line failed. I expected false to be false, or to be truthy, and it wasn't. So that's the most basic test we can get. And we'll see as we go through our testing, all of our tests have that describe, and all of them will have the it. So from a component standpoint, I always use external templates. For my components, the Angular CLI project that's generated uses external templates as well. So that's what we're going to cover here. You don't have to use external templates, and the way you test is slightly different, but their standard really is external templates. So first thing we see in our component is our typical selector, our template URL, and our styles. And then we get our class. This one just has a variable called subject with string equals world. That's the main thing we're going to play with here. So now that we have our module or our component, we need to configure it. So when you start up your components, they belong to a module. So we have a testing module called TestBed. This creates its own module for Angular, and you only have to include the stuff in the module that you need for that specific component to test. You don't have to include everything else. So nice and lightweight. And you configure it with testbed.configure testing module. You get all the same stuff you expect for a module. Imports, providers, declarations, schemas. It's just a normal module, just wired for testing. And then you get before each to reset your test module before it runs every one of the tests. So that's where it will reconfigure the test bed each time and reset everything. We'll see that here. Two things we need to import. The top line, we've got to import async. So async is very important for our before each with external templates. The process of reading the templates is an asynchronous event, and by default, before each is synchronous. So if you don't import that, we will have some issues. Then we want to import testbed. They all come from the Angular core testing. And then the second line, we import our component here. Then we see our describe that we had before. And now we have this before each with the async. We say testbed configure module. In this case, we only need to import our one component for the declaration. We tell it compile components, which says go and read the template, compile everything that I need for the component to actually work, and it returns back a promise. And we'll see this is the spot where we'll be able to get references to the component. And that's where we start doing our create fixtures. So in testbed create component, we will create an actual instance of the component we want to test, and we'll run, or it'll return back our test fixture for us. And a very important piece is it closes our testbed to any further configurations. Let's look at what this adds in. So first thing that we do on our import statement that has async, we import our component fixture. Then we'll set a variable so we can use our fixture all over the place. And then our promise, we say testbed.createComponent, and creates our simple component so it's ready and wired up. Then the last piece is actually getting reference to the component instance. So our component fixture will actually give us the handle to our test environment. Then we say fixture.component instance to access the actual component, which is just like it sounds. Component equals fixture.component instance. And then we start doing test here. So in our it, we can say expect component.subject to be world. The one thing it doesn't do here, it doesn't do change detection. So far, we only tested the TypeScript file. So we didn't need to worry about change detection in the UI. But component fixture.detect changes is what will trigger our change detection for us. Because by default, testbed.createComponent doesn't trigger that for you, which sounds like a bad thing at first, but it's actually not. By not auto-triggering it, it allows you to control, do you want the actual change detection to trigger immediately, or is there other setup stuff that you want to do with the component before you trigger the changes? Like say I want to change the subject to something besides world, and then trigger my changes. If I went the other way, I'd have to run a couple times change detection, which would make my actual test slower. So this way I can control it. So within our promise that got returned, we'll say, when the fixture is stable, then go ahead and actually trigger our change detection with fixture.detectChanges. You'll also run that same .detectChanges anytime you make changes that you want the UI to reflect so that you can then test it. And the last piece for the component is our debug element. So a few things it'll do. It'll give us access to the component's DOM. We can say .query to query the actual DOM with selectors, or we can do it by CSS selectors. So typically we'll wire up an element equals fixture.debug element so that we only have it wired up one place and then our test can access it. So this code we've gone through so far is pretty boilerplate code that pretty much every component you're going to copy this into and look at. And run it. So now that we've run our detect changes, we've gotten access to our element through the debug element, do something like get a reference to the H1 element, and we can check to see, is the actual text that got bound to it hello world? So that component already had hello in the HTML, and then the subject is what the world came out of. So now we've done two tests. We tested that the TypeScript file had the right values, and now we've tested that the UI actually had the right value for it for what it should look like. Any questions on just basic component testing before we start looking at services with it?
I saw in one of you when using compiled components, and you switched over to, instead of doing that, you went straight to create a component and you did not compile. Does that mean we get?
That would be a bug in the slides if you caught that.
Okay, all right.
Yeah, you always want to do TestBed, do all your module configs, then do .compile components, and then have the then promise that gets returned, and then get all of create your component, get your debug elements. Yes, then hopefully it's not missing in the slide, but. It
was only in the last one.
Okay. So let's look at services here. So before, we just had the subject actually hard-coded into our component. So now if we just move the subject over to a service, so we have a service. And now we actually have a dependency where we're going to import our service. We're going to create the constructor and put the service in there for our dependency injection. And then we'll change our subject. Instead of being hard-coded, it'll get it actually from the service. So pretty typical stuff that we do with services. Inject it into our constructor, and then we can use it somewhere in our code. Big caveat, you should not use real services in your test. You want to use either a testing double, a stub, or a spy. So
question on the last slide.
Yes.
I'm sorry to interrupt you.
Oh, no problems.
You did the assign operation on your property before your constructor ever fires. I was under the assumption that your assignments on properties fired before your constructor. Is that incorrect?
It's a great question. I'd have to actually test it.
Okay, all right.
Yeah.
I'm sorry, that was off topic of this, but
That is a good question. So test double basically is a mock of your actual service. A stub just returns back hard-coded data. Test double and stubs are very similar. Then the spy is something built into Jasmine and say, when I see this call made, go ahead and return this value, so it never actually calls the service. There's no additional code outside the spy, and we'll see that in a couple spots later on. And to use our test doubles, everything, we actually need to overwrite them in our provider with either use value if you want to send back a specific value, or use class. And so we get typical variables. So we're going to set up some stubs. We're going to set up our service. So in our stub, it's nothing more than exactly what our current service looks like. And we're overwriting the service variable there. then we can see in our providers, we have to say provide greeting service use class greeting service stub. So that will tell Angular anytime I go to use my greeting service, instead of actually calling the real service, I'm going to call that stub, and that's what I'm going to get to use. And then to get a reference to the service, we go back to our debug element, and we can actually get reference to the injector and pull out the service that it injected for us. So we say our debug element .injector.get and give it our service name, and that'll automatically return back our stub because that's what we put in our module to provide for us.
I've also seen it done as global testbed.get. Is there a difference between the two?
I've seen both, and I don't know that there is a difference.
Okay.
And I've done both. I actually have slides later on where I set testbed to a variable, and I say testbed.get.
Okay.
Yeah. I don't think they've decided because half the examples are one way and half they're the other way. So now that I have my service reference, I can set my service subject name. I can say fixture.detectChanges. Then I can do my normal test, just like I did before. Look at my component TypeScript file, see what the subject is. I can look at my h1 tag, and I can make sure, since I set it to Cosmos this time, that it says hello Cosmos. So same test as before, now just using a service. So that was how to do it with a stub. We're going to look at spying on the service. It's very similar. In this case, we still got our subject, and we're going to actually make it this time more async. So we're going to return back some promises. And we'll set it up. This was what we had before, and now we're going to set it up so that we get our greeting, our subject, and our punctuation all out of a service for us, all asynchronously. From a testbed side, everything is very similar to last time, except you'll notice on the providers line, we don't say use class. Right? We're injecting the real service right now. We're getting a reference to our service like before. But now we're going to say, inside of our it, instead of just being a function, it's going to be an async function. And we're going to run a SpyOn event or method. So SpyOn is something built into Jasmine. It's globally available with how they have it configured. So this says, for the greeting service, anytime I see a call to get greeting, I'm going to automatically return back a promise.resolve greetings. So it never actually will call the real service. It'll intercept it behind the scenes for us. Then we just do our normal testing. I'm going to expect my greeting to be greetings, since that's what I told it to hard code back. So same kind of concept, different way to do it from stubs. So we got a little something called fake async. So it'll make it act much more like async. So instead of async in the top line, we're going to have this fake async. We still have our same SpyOn, but now we're going to do some fixture detect changes, and they have this tick method. Tick basically says, wait for a given amount of time. It's somewhere in the neighborhood of about a second out of the box. You can always pass it in a time for it. And then I'm going to call detect changes one more time from the tick. And then I do the same test as before. So this is much more applicable to how a normal service would kind of work. The one before instantly returned back. This one will wait a second or so and then return itself back. So kind of a nice way to get a little bit of a pause in there to make it look more like a real service and how the real service would act. So inputs and outputs. Absolutely.
How would you prefer something ours? We're actually mocking out the services. We don't mock out the logic, but we mock out the methods, and they allow us to get the instance of it and then overwrite. But what if we have to create mocks of all of our services and their methods? And this seems more beneficial in that we don't have to create those mocks. But I can see the potential downside of if I forget to spy on something, I get the executing logic and the other, and I'm not really like isolating it.
Yep.
Is there, what's your opinion? Which way is more preferable?
Depends on how much stuff you're doing in your spies. If your spies start going like, hey, we've got all these spies, it might just be easier to do the mock. I've gone back and forth. I haven't really come to the conclusion one way is better than the other. I have the same worry that you have with the, hey, what happens if I forget to actually mock out or spy on one of those things? Am I going to really call the backend service or not? One of the things I'll do a lot of times, because my backend services typically are all HTTP, I'll actually mock out my HTTP so it'll automatically override all the gets and just return a blank array so that you never actually make a real call back. Like, that's typically the way that I kind of get around that. So even if I screw it up, it doesn't make a real callback. And you'll see that when we start talking about services with the HTTP in a little bit.
Okay.
Any other questions? So components with inputs and outputs. So the goal with testing the input and output is just to make sure our binding is actually working. For our input, we just need to update the value and then ensure that it actually rendered. For output, we're going to trigger the trigger event handler, and we're going to subscribe to the event emitter to make sure everything worked. So similar template that we had before. This one has it baked in line. So we have a subject, and then we have a button that has a click event on it. We have input for the subject. We have output, which is an event emitter for the leave, and we're going to call our event when we click the button. Pretty simple component here. As far as setup, we have our typical before each. Same thing that we had before. We're going to look up our button by CSS. We're going to set our component subject. We're going to hit our detect changes. We do this all in the setup. And a lot of times I will do this kind of stuff in the setup if all of my tests are going to be using those pieces. That way I don't have to keep writing those same 3 lines of code in every single test at the top. And I just do the same test as normal for input. I'd already set my subject, so now I'm just going to check to make sure it's what I thought it was. And we'll see our component has a little, or our output has a little bit more code in here. I need to subscribe to the actual leave event and set it to something. I need to trigger my button. And I've seen a lot of examples where they do button triggers where the second argument that says button:0, they'll put as null. I've noticed somewhere in one of the Angular releases, that seems to no longer work. I think at one point they automatically triggered the left mouse button, which is what button:0 is, and they've quit doing that. So I've noticed a lot of my button triggers stopped working. So just throwing the button:0 there for the left click. And then I can make sure that my what got emitted from the event is actually what I expect it to be. It's a pretty simple way to trigger the button and get all my events working.
That's actually really interesting. I've seen in hours where you just do the dot click, and the downside of it is the Chrome window doesn't have the focus, the unit test is there.
Yeah.
So you're like, all right, well, I know this one just fails because it does it. The window doesn't have the focus. That's been really annoying.
Yeah, and I actually have, in the code repository I'll give at the very end, I actually have a testing helper file that has a click event in it that automatically does that for you and triggers the event. You just pass in what element you want it to trigger on. Because I got tired of typing that same code over and over. And it used to actually be in the Angular 2 CLI projects, and when they went to Angular 4 somewhere, they dropped that file out. So I brought it back. So now onto some forms. So far we've looked at just components. Forms obviously go on components. We're only going to look at one kind of form, which is reactive forms, because the forms module isn't unit testable. Only the reactive forms is unit testable. So things we can test: validation errors. Are our fields valid? Is the form valid? What error messages should be showing up? And did the error messages actually show up? So it's pretty easy to get the reactive form set up. You import form group, form builder, validators. I also like to import debounce time so that my validators don't instantly fire the minute somebody touches the field. That's such an annoying user experience when you go to type your email address in on a form and it instantly tells you it's required, and then you type a character and it tells you that's not an email address. It's like, really, could you wait at least a second for me to stop typing? So that's what debounce is for. Then to set up the form, this form has one field called item. It has two validators, required and a minimum length of 3. Then I also wire up to look at all the values when they change. So I have a very generic error or validator error handling that will look at all of my different fields and spit out the appropriate messages. So after a second, go ahead and run the onValue change. It'll look at a few things in there. I set up what fields do I actually care about as a placeholder for my errors. What errors do I want to show up if they're triggered? So for the item field, I want required to say item is required, and the min length to say item must be at least 3 characters. Here's where all the magic works for this validation. So onValue changed, I get reference to the form. I look through all of the form error fields that I've set up, get a reference to that field, and I can make sure I found the control. I also want to look to make sure the control is dirty, which means they've typed actually something in the field. Even though I'm debouncing, nothing like looping through this for one field and having them all trigger still. So this will make sure they've touched it and put something in it. But I'll also check to make sure that it's still invalid. Then it gets the references to all of those validation errors from the previous slide, and it will loop through all the errors that got fired from the validators and keep appending them so I get one message back out. So to test this, I've got to import the reactive forms module. Then I'm going to import an abstract control and my validators. Because behind the scenes, all of the controls inherit from abstract control. And the only thing that's really different in the test bed is the imports. So now I've added an import statement because I need to pull in the reactive forms module. And because all of my tests are going to be playing with the item field, I just have a globally available item field where I get a reference to that component field, and then I make sure that it actually got found. That's one thing you'll definitely want to do as you start setting up different things like this in your test, is make sure it actually had some value that you expected. There's nothing like your setup failing, and then everything else fails and you don't know why. So even though I always expect it to be there, you never know. So first thing that we do, set a value. So our field by default is blank. Thankfully for all of the reactive form fields, they have a set value function. So we're going to set it to something, grab all of our errors. So in this case, our errors should be nothing, because we said we wanted it to be required, so we have a value, and we wanted it to be at least 3 characters. So we've got 4 characters. So then we can test to make sure, do I have an errors required? Or it should be undefined, and then min length should also be undefined. And I can look at validity of the field, of the form, and I can also loop through and make sure that my actual form errors that got generated from that last slide should be nothing. It's an easy way to make sure everything's set up right, make sure my validation's set up for grabbing all of those different validation messages. So this slide is all about everything passes. So this one we're going to take a look at min length validation. So I'm going to say set value, only give it 1 character. And this time I should see min length is defined. And required should be undefined. And it's really funny, I don't think I have a slide for this, but when you have required and min length, you would think if you set the field to blank, both might fire. It doesn't. Only required actually fires when the form field's blank. That one took me by surprise when I started doing unit testing. I thought both of them are probably going to be there because it's blank, which means it's less than 3. But they said somewhere behind the scenes they must say required takes precedence over min length, so only fire one of the 2. My field at this point should be falsy. My form should also be false for invalid. And I should see that my form error message that gets spit out should be whatever the item min length error message was. I don't have it in here, but I could take it a step further and even get an access to the element that's on the UI and test to make sure that that error messages got put into the element on the UI as well. That'd be the next step for this. There's a few gotchas in here. So technically, guarantee half of those tests fail if you run them exactly like they were, because there's a couple things that I didn't show yet. By default, when you call set value, it doesn't set your field as dirty. So if you remember the error validation, it actually looked for the control to be dirty. So the control is never dirty when you set it programmatically. That's meant to be a UI thing. Thankfully, there is a way to actually mark your fields as dirty that we'll see in a sec. The other piece that I could not get working without overriding it was the debounce stuff. Supposedly, you're supposed to be able to hook up into the async and it's supposed to wait for it to be done. There's actually a couple GitHub issues open around that not working correctly. And I definitely noticed that I was starting to get stuff like, you still have something in the queue waiting to happen when the test was done. So there's a way to override it that we will see. So first thing, marking the field dirty. So in my before each, in that field reference, I say .mark as dirty, which takes care of setting that field as dirty. And I just leave it as dirty since I'm only using it for validation and I always want it to be dirty. Then we have a new thing here, before all. So far we've been looking at before each, which ran before every one of the tests ran, or before each one of the tests ran. Before all is the very first thing it will do before it runs the very first test. So we actually want to overwrite how the observable debounce actually works, just to set it to say immediately return versus having a set timeout that waits. So it basically sets debounce back to 0 so all the tests will pass. That will throw you for a loop if you're using debounce because it is not obvious that something in the queue still is what this error actually fixed. So HTTP services. So we saw SpyOn a little earlier. So we're going to do the SpyOn for the HTTP calls as well and not call the actual backend service. Here's how I get around mocking out the HTTP. So I do get, post, put, delete, patch, head, request, which is basically all of the functions that are part of Angular's HTTP, just to have it return back an empty array for the response. And the mock HTTP response is basically this file that says, go ahead and return me back an observable that has a new response that stringifies the body in here. So this way, even if I do forget to mock it out, it's not going to make an actual call to my service. You're supposed to be able to use something called mock backend that's built into Angular. I have yet to be able to get that working correctly, and I've yet to find the documentation, and they have not updated their testing guide actually on how to use it yet. So this is what I found to get around that between this file here, mocking everything out with the appropriate response. Now when I go do testing, I import all of that stuff, except some variables for my service, my HTTP, and now when I provide my HTTP provider, I tell it to use the mock HTTP class. Get my references to both my HTTP as well as my service. And here's where the spying is going to happen. So I set a couple things I wanted to return. And in my spy, I tell it, spy on the HTTP get and return me back this observable, which technically is the mock response. I put the whole code in here so you can see what it was. And one really cool thing I found with TypeScript is you'll notice the bracket ... to-do items. That says basically make a copy of the to-do item, so even if I change it, I never change the original. It's kind of an interesting little trick. So now that I'm spying on my HTTP get, when I run service.getAll, which is doing an HTTP get, I can subscribe to it, and then I can run all of my expect statements. So I expect the result to come back, which equals my to-do items. I expect my result to have the same length. So never made that actual call to the API. It still ran my service code, which is one of the things that I like to do. 'Cause sometimes your services do have logic in them, and really what you're trying to abstract out is your call to your database and your backend. Again, but you don't want to abstract out all the logic that happens when data comes back. So by just taking the HTTP and spying on that, I still get to run all of that other business logic that goes on in my service. So did that answer your question for the HTTP traffic that you asked earlier? So last piece of components is routing to them.
Can I ask a question on your,
Yes.
you pointed out the TypeScript array spread operator. I wonder, is it actually copying it because you're transpiling down to a lower version of JavaScript that doesn't support spread? And if you transpile to a version that did support spread, would you lose that object copy? I imagine it might copy the top level, but you still keep the references to the objects within the array.
I have absolutely no clue.
Okay, all right. That was interesting. I've run into this
Yeah.
problem before, and I've done it by like stringifying and then parsing in order to lose all deep references. But that was interesting.
Yeah, that's what I've done in the past too. And then as I was researching for this talk, I ran across that in a couple of logs. I was like, oh, that's what that is.
I would be
Yeah.
curious to transpile it to like an ESLS16 and see if it contains that same functionality, or if it's just like a byproduct of the translation.
It'd be something to test.
Yeah.
So when we do routed components, we really do want to avoid our router complexity. The router is a pretty complex beast, and we don't really want to test the router at all. So they have something built in called Router Testing Module. It's a fairly new testing module that's meant to stub out a lot of the intricacies of the router. You will find when you try to do testing for the router, or find docs for the router testing module, they are a little lacking right now since it is so new. But it allows us to test that our component actually navigates to the proper routes. So make sure our router links actually have the route set up that we think, and make sure that when we click on them, whether it's a link, it's a button that's going to navigate us somewhere, that it actually went to where we thought and the location got updated. So 3 things that we need to import: our router testing module, our spy location, and then the actual location. So we've seen this bit of code already that's all highlighted. Typical before each. What's different in here now is we're going to get, from the injector, we're going to actually get the location. We also have a router testing module in here where we configure which routes we want to play with. This is definitely, if you've done any testing, this will throw you a little bit. It used to be that the router testing stubs automatically had all the routes in there. Now you actually have to define which routes you want in there. So I've ended up in a lot of cases where I'm just testing to make sure like my menus got everything set up. I'll just put every one of my routes to the same component just so it passes the test, because I'm not testing did the component load, I'm testing that the location loaded. So that definitely throws, I kind of wish that when you called with routes, it would just look at your routing module and just wire up all the routes. It does not. So once you have that configured, the first test we're going to look at is in your UI, you can say router link and give it a location to go to. We're going to look at testing those, make sure that it goes to the right spot, that we get all of our router links, however many we think there should be. So we need to get that from router link with href. Then we say fixture.debug element query by directive router link with href. That will get us every one of our router links that's on that component. Then we can test the length to make sure if I expect one, did I actually get one router link? So I use a lot of times in my menus, did all 5 or 6 or however many links are in your menu, did they all show up? And then I can start actually looking at location checks. So because we're going to use the tick operator, we're going to import fake async. We get our same, all of our links like before. We're going to pick the very first one. I'm going to make sure I haven't navigated to it yet, so the path should just be blank. I'm going to trigger the click handler for that actual link. I'm going to do the tick so it waits a sec. Then I'm going to check that it actually routed to /items, which is where the route was actually set up to go to. So easy way to make sure all of my routing is actually working without playing with the router complexities. So not much to the router stuff here. Any questions on routing before we move on to a little bit of Jasmine goodness? So some Jasmine goodies. So first thing when I started playing with Jasmine that drove me nuts is how do I run just a subset of my test? As your test suite grows, I don't want to run all of my tests if I'm only playing with one component or one service. I want to run just that test. Makes my test run way faster. So instead of that 5 seconds for the 46, I get 0.01. So it's always running. You literally add an F in front of the describe. That will take everything that's in that describe, and those are going to be the only ones that get executed. So yeah, and then you check it in. Yes.
Somebody commits the app.
Yes.
Can we put a linter rule in?
Oh, yeah.
No describe, no updates.
Yeah. I have actually checked that in myself before too.
Yeah.
Yeah. And then you quickly realize,
So is there another way to do it?
I have not found another way.
Because like a lot of
Yeah.
other platforms, obviously, I don't know, everybody here has done backend work, whatever. Like, I'm familiar with my IDE, just hitting Control Shift F10.
Yeah.
Whatever whatever test I'm on, it'll just run that
Yep.
test in the IDE, right?
Yeah. I have not found a. Yep. Yeah, I have not found anything with Jasmine that, because normally it's a UI that does it.
PR, if it's a possible thing. Maybe
Yeah.
it's just like the way it's architected, it's just really hard
Yeah.
to walk.
And I think it's because there's not an actual UI where you pick the test to run, where most of those where you can
It seems
pick the
like
test
the
have a.
UI list that's loading the
Yeah.
browser, like, just needs a parameter on it that says run this like particular test.
Yeah. Well, in the case of Karma, it doesn't. Yeah. Because each of the tests doesn't have its own URL, which is part of the problem. It's just a general that says run everything. It would be nice. It's just, yeah, it's just the way. Karma's the test runner and Jasmine's the framework. And so fit and fit describe are a Jasmine thing. You can also group test. So it's a great way to split some of the tests up, especially if you have different before eaches. So a lot of times I'll split, like in this case, I'm testing my menu. I want to actually split up, can I actually get the component to create? Can I do navigation? And is my menu actually toggling when I go to a lower screen? Does it hide and show the menu if you click on the hamburger button? Each of those have different things I want to do in the before eaches. So I can nest all my describes. The really nice part when you nest the describes, each level can have its own before each, and it will run them in the correct order for you. And once I split them apart, I will split out my test setup as well. For the one that every one of them is going to want to potentially run, I can split them out and have my before eaches. Then I just create functions like normal. Call my setup, run all of my tests within there. So nice, easy way to split buckets of functionality. And the fdescribe works at any one of those levels as well. So now we've seen all of our code. Guarantee unit testing will make you faster. It'll confirm all of your functionality. It'll check all of the regressions. Right now, for the simple little to-do app that all this code was based off of, 46 unit test runs in less than 5 seconds. And I know functionality is working. I couldn't go through the app within 5 seconds. Heck, I can't even get some of the routes to load up between pages in less than 5 seconds for all of them. It helps me pinpoint all of my bugs, hopefully before the users find them. And it's a great way to document functionality. If I just look through the unit test, I should have a good understanding of what are each of the components and services doing, what kinds of data should I expect to get back. We already know it should be automated, should have a single unit of work, and we're checking single assumptions. You notice every one of our expect statements looked at one single thing. We didn't have it looking at multitudes or running a function that looped through a ton of stuff. One item. We saw a good unit test. They're maintainable. They're dependable. And they're runnable over and over again. Some resources for us. They have a huge Angular testing guide on the actual Angular website. Things like 140 pages long. Covers about 90% of the stuff. And they are continuing to grow it as they add in more functionality. For some of the stuff that I mentioned where they didn't have docs out yet for it, I saw some comments in some of their testing samples that said, future version to update for whatever the latest release was or latest functionalities. They definitely know they have some gaps in there as they've changed stuff around. So I expect to see that continue to get updated.
Now that you've gone through all of this, you can be a contributor.
I could. I tried to figure out how to use some of the stuff, and I definitely did not figure it out.
I'm pretty sure it's all in GitHub, right?
Yep, all of their documentation is in GitHub. There's a big code repository that I have for the application. So it's pointing to a specific branch. On my website that you'll see on the next slide, I have an Angular workshop that has you building the whole app. The unit testing chapter is not there yet that walks you through creating all the tests, but the code is in the unit testing branch. Hopefully, within the next 2 to 3 weeks, I will get that chapter written before I go to a conference to give this talk. All of these slides are available on slideshare.net/digitaldrummerj, and you can actually see all my slides there. My website, digitaldrummerj.me. You can find me on Twitter @digitaldrummerj. Thank you.